everyone. Welcome to the session PR35 of Zero Build Forum. As we all know, this is the third day of the event, which is focusing on passive houses, and today is organized by ZEBesco. ZEBesco is Zero Energy and Passive House Association of Turkey. I would like to thank to all ZEBesco board and all, of course, Zero Build Forum Secretariat for this very successful event. My name is Özgür Alioğlu. I am the Deputy General Manager of ODE Insulation Company from Turkey. Today in our session, we have 4 speakers. As maybe you can see now, it's really a multinational session, I can say. I would like to introduce you, our speakers first. Mr. Dimitris Pallantzas, he is the Education Officer of Hellenic Passive House Institute, and he is coming from Greece. Hello, Dimitris.
Hello, Özgür. Thank you very much. Very nice to see you, all of you,
very
once
nice
again.
To see you also. Very nice to see you also. And Kumsal Çakır, Miss Kumsal Çakır, she is from Turkey. She is the founder and architect of TurkeyKU Architectural Design Studio. Kumsal, welcome.
Hello.
Our third speaker is Mr. Mohammad Heidarie.
Thank you.
Hello, Mohammed. You can hear us, I think. Our third speaker is Mr. Mohammad Heidarie. He is the managing director of ZEBesco, Zarir, Behin, Sazan energy company, and he's from Iran. Hello, Muhammed. And our last speaker is Mr. Muslim Mohammad Raheem from Iraq, and he is the founder and CEO of Passive House. Yes, he is the founder and CEO of Passive House Iraq.
Good evening, everyone. I am so glad to here today. Thank you.
Thank you very much, Muslim, being with us today.
Yeah, that's correct. Yeah. Hello, everybody.
Hello, Mohammed. We have 15 minutes for each presentation, and at the end of the session, we have 20 minutes for question and answers. Now, I would like to give the word to our first speaker, Mr. Dimitris Pallantzas, and his speech will be about how to design a zero-energy school kindergarten in Athens. Dimitris, the stage is yours.
Unfortunately, at this moment, I have some connection issues. Normally, I have it works. Can you hear me now?
Dimitris. So I think it's better to start with Kumsal.
Sorry?
Maybe at the time Dimitris can solve his problems. Kumsal, can we listen your presentation? Is it possible?
Okay. Just a second, I will share my presentation.
Yes, we can see you.
Okay. So, hello again to everyone. Mr. Özgür, thank you for the introduction and the hosting for such an organization. Today, I want to present a passive house project in the Mediterranean climate. I would like to give information about the project process and our experience rather than our project. Passive house is a system that can be applied for every climate. The most common practice is for cold climate regions, and therefore the literatures and practices for cold climate is more advanced according to hot climates. Mediterranean climate is characterized by dry summers and mild wet winters. As you can see on the map in the presentation, the Mediterranean climate is located in a limited area compared to entire world mass. And my first passive house project is Ark House, which is located in Izmir in the Mediterranean climate. And it is one of the first projects built as a passive house in Turkey. The Ark House project in which a family of 5 will live was actually a project with very minimal needs. You can see the floor plans in the presentation. We have a very compact and practical plan. However, our difference from many passive house projects was to meet the passive house criteria in summer conditions. I think Mediterranean climate is the most pleasant and non-challenging regions to live, at least in my personal opinion. As a common practice is try to provide passive house criteria for winter conditions in cold climates. But we have made an effort to provide passive house criteria for summer conditions. As you can see in the presentation, there is a verification segment on the homepage of PHPP, which is Passive House Planning Package. We use this program in Passive House Planning. Here in this page, you can follow whether the necessary conditions for the passive house are met, and space cooling is an optional for the passive house, which describes summer conditions. However, it is optional if you really want to do environmentally sensitive design in a region such as the Mediterranean climate. It can't be optional because it's really easy to provide the values required for winter conditions in this region. But unlike common projects, we made an effort to meet the criteria for summer conditions. The fact that our project is one of the first projects to be certified in Turkey, and also it is located in the Mediterranean climate, has led us to new discoveries about some design decisions. The heat gain in the summer and humidity have become one of the most important issues that will ensure the thermal comfort of the project. For example, even if we wanted to open a skylight in the roof, the calculations that we made didn't allow. We only could make a skylight about 1 square meter. Then we decided that we didn't need to break the insulation for this. However, apart from that, the passive house system didn't limit us in terms of design. This was just an extreme example that I really surprised about effect of the roof window. Although we are in the Mediterranean climate, we applied the 5 basic principles of the passive house system in our project. I think it's talked too much in decisions, but maybe I can tell again the 5 basic principles of passive house. First of this, it is very high level of insulation. We used 24 centimeters of EPC on the walls, but we use 5 centimeters of XPS on the basement floor because we need to lose heat from the basement. And of course, we use extremely high performance windows with insulated frames, and we supply airtight cooling envelope. We thermal breach-free design, and we have a mechanical ventilation system with highly efficient heat recovery. While doing our work, we tried to compare all components in terms of price and performance. For this, having a program like PHPP made our work much easier. We didn't act by heart on any material. Of course, we faced some difficulties in process. In fact, although the passive house is a very clear and simple system, we encountered some problems due to unknowns of the system in newly implemented regions such as Turkey. When we communicated with subcontractors who didn't know about the passive house system, we had difficulty in being understandable when getting information. Unfortunately, we received a lot of criticism about why we are dealing with such a thing, especially if it is worth the effort for a single house. I think this is one of the most challenging parts of the project. The lack of certified local products and our limited options were also factors affecting the process. I think passive house is a team effort. The architect, the passive house consultant, the customer, and the contractor have to work as a team. And I think I'm really lucky in the customer part of the project. First of all, it was Athens. He's my customer who said he wanted to build a passive house. Every project has a potential, but if there's no consciousness customer, the project sometimes cannot even use the potential. we had some misfortunes in implementation here. The fact that it was one of the first projects in Turkey and we wanted to test every material, and we had a hard time getting enough support from the contractor during the process. However, we continued to our work even if our process took a little longer than we expected. Sometimes it's not possible to achieve good design, low cost and fast at the same time, not only in the passive house projects, but in every project. But I believe we have optimized the project as much as we can. You can see some construction photographs from our project site. We still continue construction and some material tests. This is a test from the roof insulation. We are making this with BSF. And this is not rocket science as is often mentioned in zero build sessions. However, as a society, we need more awareness and education. This should be a process that includes everyone from the worker to the architect. Then we will see how the passive house system is practical and easy to apply. As an architect, I see that the only useful job maybe I contribute to the environment is to take part in the passive house project. And I wish these projects to multiply in Turkey and similar countries. And also I hope to present you with more project examples from Turkey in the following years. And as a good news, I am doing second passive house project, which has started in Saray, Turkey. It is not in the Mediterranean climate, but it's in Turkey. And I hope in Turkey we will have more environment-friendly buildings in next years. And that's all. Thank you for this opportunity.
Thank you, Kumsal, for this very lovely presentation. It's really good to see examples from Turkey because as far as I know, except the passive houses that is done by SEDA, this is maybe the real private investment in Turkey. So congratulations to you also about this investment. A little question for you. You said you have started the second passive house project in Sakarya, and you want to present more examples in the future. What is the basic lesson that you took from the first one? I mean, what will you carry to the next one, and what you will not carry to the next one?
I think I will not listen to all subcontractors. I will follow my route because they take your how can I say they take your efforts, and sometimes you start to be sad. I think I will listen just my heart.
And the passive house institute.
Yes.
Okay. Thank you very much, Kumsal, for the presentation.
Thank you.
If there will be any questions, I will forward them to you at the end of the session also.
Okay,
Dimitris, I see that you are with us again.
Yes. Hi, Özgür. Hi, Kumsal. Hi, Mohammad. Hi, all of you.
Not to prolong the discussion more, stage is yours, Dimitris, please.
Hi, everyone. Thank you very much for the invitation. It's a pleasure to be here. So let's share my screen and start. Can you see my screen?
Yes, we can see it now.
Perfect. This particular presentation is about how to design a zero energy school and a passive house kindergarten in Athens. But first of all, one very often question that we're having the past years is, does passive house stop architecture? Because it's a very common issue, especially from architects, that with a lot of insulation and lack of geometry, a passive house doesn't help the architects to design and to use their imagination. But this is not true, because as you can see here, there are multiple passive house non-residential buildings. At the left-hand side top, you can see a fire station, then in the middle up a church, then an office building, and from the left-hand side down to left to right, there is a school, there is an office, and there is a gym. So actually, passive house is not a matter of architecture, it's a matter of energy efficiency. So this is some examples of passive house schools in all over the world. And schools are very, very important for us for several reasons, not only in Greece or in Turkey or in the Mediterranean, but in all over the world. Because, and this is a question, why we select to do this work and to invest our efforts in schools. Imagine that if one child asks for something, an ice cream, toys, a video game, is 90% that he will get it. So in Germany, during the last year, there was 2 identical schools, one passive house and one not passive house. So after some months, the indoor quality and the temperature inside the passive house school was 100% better than the conventional one, even in Germany with a lot of insulation. So the kids actually was begging their parents to go to the other school. So this is a start to convince the society that indoor air quality and indoor temperature quality, so internal conditions, are very, very important for us. And especially in 2021, we should have the best possible conditions because our science let us do it. So imagine the kids to ask for passive house. So we are targeting municipalities, government, regions, private school, or funded projects. And the last 2 years, we have now this passive house kindergarten, which is under construction. It was designed from students. So we had 13 different studies, 13 different designs for the same plot and for the same kindergarten in our student competition. 32 teams participated in this particular competition, and we offered to the students more than 250 hours of passive house education and architectural workshops. So the result was amazing. The mayor was amazed because he couldn't believe in his eyes, and our jury select the 3 best studies in terms of architectural design and energy efficiency. So now the municipality is starting to build the first study, which is the top left building. We will see later on. As Kumsal said, we used the 5 basic principles plus shading, which is highly important for us. We are considering shading as the 6th basic principle in climate zones and climate areas like Greece or southern Turkey, because it's pretty important, especially in non-residential buildings where the internal heat gains are extremely high, especially during the morning. But during the evening and during the night, we can easily use the night ventilation to free cool our building. Apart from the 5 basic principles, we have some key points, which are the definition of the number of the definition of the users. We should be very accurate with the number of the users, because as persons, we are almost 80 watt. So we need to take into consideration that if we have to have kids or children or child who will play or professors, or it's pretty important to define our internal heat gains. Normally in the school, we don't need active heating even in a very cold winter, especially in our climate zone. So the key to maintain the perfect indoor conditions is to preheat, or to preheat mainly the school 1 hour before the arrival of the students, of the children. So preheating and pre-cooling in some hours of the day is pretty important to maintain the perfect conditions. Night ventilation is extremely important also because you can earn multiple gains without using active cooling during the night. Thermal mass is also very important because the thermal capacity of the building elements and the structure of the building is highly important in order to achieve perfect indoor conditions in terms of radiation of the walls, of the roof, of everything. So it should take into consideration. Heating, cooling, and ventilation distribution is also very important because we have in non-residential buildings we have different rooms with different usage. So we need to design a very clever system. Fire protection is also very important, and at the end, use proper materials. Proper materials in terms of hygiene, in terms of safety, and in terms of the use in schools. There are some very detailed papers which describes very well how to use each material in the schools. So this is the kindergarten. It is a very small building with 177 square meters of third floor area. The users will be 21, together with the professors. It will be constructed in Athens. It was designed by the team Pass to Use, a team of 6 students which did an amazing job. And it will be Passive House Classic, the category. It is Passive House Classic, Plus, and Premium. This is one section. As you can see, we will have one unheated basement, and we have one big classroom, and then smaller rooms, multi-purpose rooms, etc. And is inside the neighbor, so it's right in the center of Moschato Tavros, a neighborhood in Athens, in the center of Athens, which helps in terms of solar gains because there are other high tall buildings nearby. But in terms of the heat island effect, it is highly affected. And thankfully, in Greece, the kids are having 3 months of vacation during the summer. So we don't need a huge cooling system. Here is one more section, as you can see. So this is the PHPP, the energy balance calculation, in which we have for thermal envelope U walls 0.215, U roof 0.133, U floor 0.278, and an average U window of 0.91 watt per square meter Kelvin. Normally, a key in the design of such buildings in Greece or in the Mediterranean is sometimes you don't need to insulate a lot the basement because you will use the basement or the ground as a sink from which the heat will go out and we will have a free cooling. In this particular PHPP, the students designed also a good insulation in the floor because, as we said and as we discussed, the building will not be used mainly during the summer. So for the HVAC systems, we will have 2 units designed with an airflow rate of 470 cubic meters per hour, heating and cooling with a heat pump of 4 kilowatts, and domestic hot water with solar thermal. So this is the design of the mechanical ventilation with heat recovery. We have some rooms from which we will also supply and extract in order to have transfer air in all over the building. I remember you that we need supply in the usage rooms, and we extract from bathrooms, from kitchens, etc. This kindergarten will not have a very big kitchen because it's small. It's a small kindergarten. It will have only one small cafe with some refreshments and some snacks for the kids. And this is how the air will transfer inside our building. It is very, very important, the concentration of CO2, because normally schools and normally kindergartens, especially in winter, have more than 2,000 or 3,000 ppms. We need to keep it in a passive house. We need to keep this number under 1,000. So with this particular design, we will achieve it. And this is very, very important for the health of the kids, for the concentration of everyone, and for the indoor air quality. So some slides about comparison with a standard building and a passive house. So our regulation give us this particular result in which we will have a heating demand of 97.5 kilowatt hours per square meter per year, and we are in 13. Cooling demand for a standard building will be in 51.3, and we again have 13.1 kilowatt hours per square meter. So it's 5 times less and 10 times less than a conventional one. And about economics for this particular building, passive house construction is 70% higher and consumes 87% less energy. Moreover, passive houses operational cost is 76% lower. So the total annual cost for a standard building will be higher due to the operational cost, as you can see. So last but not least, indoor quality. I talked a lot about the air conditions and the indoor quality of a building, because even in Greece, a lot of schools are suffering from energy poverty, and we're seeing that every single winter, and kids are complaining, parents are complaining, and you can imagine that in a country with a very low delta theta temperature difference, it's crazy to cannot warm a building with or a classroom with 20 students and so many internal gains. So this is a conventional one, and this is a passive house. So this is why we are targeting schools, and this is why we think that schools and kindergartens are highly important for our society and for the awareness of the passive house concept. Thank you very, very much.
Thank you, Dimitris, for the presentation. Your presentation and your experiences are very important for us because as Greece and Greek Association, you are in front of us. So your experiences are really putting a light in front of our way. Just a question to you. Sure that there will be more questions at the end of the session, but I mean, how did you manage to convince the state or the government to start passive house schools?
This is a very good question, Özgür. This is a very good question, and this is a work of 10 years. The government, we didn't convince them. I mean, we're targeting municipalities and we're targeting mayors with a vision. So now we have this particular school in Moschato in Athens. We have another one from Retrofit in Trikala, and we will have 2 more. Now we are designing with our team in Trikala, in Larissa, excuse me. So you can convince a very few people, and it's very, very difficult. So it's a very good question, and I hope that you can achieve it also. But our government it's far away from being convinced about this.
Okay, probably we will have the same issues in Turkey also, but this is a good hint that to start from the local managers.
Exactly.
Instead of starting
Yes.
from the whole country. Thank you very much, Dimitris, for the presentation.
Thank you very much as well.
Now, our third speaker, Mr. Mohammad Heidarie, and his speech will be about Iran's first passive house building design and construction. This is a very good session. We are always talking about the first ones. Mr. Mohammed, the stage is yours, please. Can you hear us, Mr. Heidarie?
Hello.
Hello, we can hear you.
Yes, I can hear you. Yeah. Hello.
We are ready to see your presentation.
Hello. Can you hear me? Hello.
Yes, we can hear you. We are ready to see
Hello?
your presentation.
Yeah. I'm just. Yeah. I will start just a second. Yeah. Well, can you see my screen? Hello?
We cannot see it at the moment. Now it's coming. We can see it now.
Hello? Can you see my screen?
We can see it now.
Can you hear? Can you see my screen?
Yes, we
It's
can
good.
see it.
All right, yeah. May I start? Hello, my name is Mohammad Heidarie. I'm going to present the first passive house building design and construction. But actually, I'm a certified passive house designer. Due to the energy problems in our country, I actually decided to make such a private building to show this energy efficiencies. Can you hear me now? Hello?
Yes, we can hear you. Please continue, Mr. Mohammed.
Hello? Yeah. But I'm going to present the first passive house building. I'm a designer and also the contractor and the builder of this building. So there is not anybody involved in this building. So there is not much problems to convince anybody else. But according to the national code, we actually had a problem to just convince the municipality to just start design and construction of the building. But I tried to make a comparison between the national code and the passive house. That is I'm to present is a multi-family, actually 5 residential units on top of that. The building is located in the vicinity of the Tehran capital city. It's actually, you can see the 3D of the building. But this is going to be an example. So I've decided also to put actually PV system on the roof and also on the facade. But this is a design, the architectural design. This is the east facade view. And this is the actually south facade view. And then the building is located actually in the warm climate zone. And I would say we have a problem during the summer power cutoff because of this cooling. Everybody use the cooling system to just cool down the houses. They use actually electricity, and also in the winter time they use a gas heating, and we also have a gas cutoff during the summertime. So according to the statistics, the building industry use almost 40% of the energy countrywide. The building location is shown here. It's a kind of the rectangular shape, the building, and to start with this passive house design, we already contacted the Passive House Institute, and they actually they were willing to join us as a certifier directly, because they say that it's going to be the first passive house in Iran. But due to some issues, we didn't launch this certification process. I would actually summarize at the end of my presentation why we didn't go for the certification process. But for the climate data, we actually used the PHI, and they actually provided the verified and accredited climate data for the building location. You can see this actually graphs which comes from the PHI. These are the climate data which we use in PHPP analysis. And then according to this data, the climate zone is almost warm in this building location. And this 3D view shows how the building looks like. Actually, we have this roof-mounted PV system, and also on the facade. This is the application of the building, which is actually there is open on the both sides, east and south, and there are also neighboring buildings which are actually one to floor, the villas or the dwelling building. To start with the design, we actually use the design PH, and then in the design PH we just got a sample climate data, which one of the cities which is available, Iran cities, which is available in the design PH database. But in order to come up with the preliminary design, the design PH is a good tool. You can actually apply all the scenarios for the insulation, also for the
maybe we can continue when he's back with us. Now, okay, probably he's having some problems about his connection. So let's continue with our next presentation. When Mohammed is back, we can continue his presentation also. Our first speaker is Mr. Muslim Muhammad Raheem, and he is from our another neighborhood, Iraq. And his presentation will be about how to build passive houses in the country which has less economics to build a passive house. So Muslim, welcome to our session. Stage is yours, please.
Okay, thanks for this opportunity, and already you provided good information, our colleague Atia, our session, and I think I gotta share my screen. Just let me, window, yes. I think you can't see my.
We can see your presentation.
Yeah. Just I'll try make it full screen. I'm sorry. Now it's good. You can see in full screen.
Exactly. Please.
Okay. And thanks again for this opportunity. And today I'll try to explain how to build passive house in poor societies. We know that build passive house in high quality societies, I think it's not difficult. For example, it's not difficult to build passive house in the center of Europe, in like a country like Germany, like Austria, or even like high quality countries, our neighbor. For example, if you want to build passive house in Turkey on other countries, I think this will be more easy. But how we can build a passive house in a poor society? Poor, it means in lack of material, and it's too difficult also reach agreement with the clients, because we know that passive house, I think today is the highest standard for building energy, energy efficiency in buildings. Before you started build passive house in any society, you gotta investigated the current quality of the buildings. If the current buildings have good quality, it means the way for you is more easy, or you can easily reach passive house standard. But if current buildings has very, very poor quality, you should hard work to reach passive house. That's really this presentation prepared in basis of Iraq society. Maybe this presentation, or maybe this lecture will be different if you want talking about build passive house, for example, in other country, for example, in Africa, or in other countries in Syria, or other countries in Middle East will be different. Just I want to let you know this presentation prepared based on society of Iraq. Before everything, if you want to build ATIA, we gotta select the quality of current building. ATIA in Iraq, as you see on the screen, most of the buildings, believe me, more than 97% of buildings have not ventilation system. And also most of the building, nearly about 90%, or I can say 95% of private buildings that people build in houses or commercial building, they don't use any thermal insulation. And also I thought it's no matter at here, because maybe even professionals, engineers, they neglected this topic. And also nearly, also we can say nearly about 85% of windows that use it at here, it's not triple glazing windows. This is the current quality of buildings. If you have information about passive house, now you can see that how will be difficult the way to build passive house. Because if you have a building of, if you are living in a society that people using, for example, 5 centimeter insulation, it will be more easily to reach passive house or to improve passive house. If the people have that idea using thermal insulation, it's good for the building, for saving energy, for also for pay of energy of electrical or gas or oil. The way for you will be more clear, and you go away with lower steps to reach passive house. As I have mentioned at here, we have not ventilation, and also this is a real image of most of the buildings at here. People use it concrete block. After this, in exterior, just finished by the render. cement sand render, and it's not more. And also in the inside, just use it wet gypsum. This is the quality of external wall. And do you know that the U value of that walls, it's so high, and it's lost a lot of energy. And also, as I said, the windows at here, not triple glazing, most of them double glazing windows. And the profile of window, the thermal break of windows is nearly about 15 millimeter, while passive house windows nearly about 50 millimeter thermal break. That's really 5% is lower quality than passive house. And this image, I think, is very clear. It's not only for passive house, it's for improving anything that you want in any society. That's really for reach anything, you have some steps. You cannot skip any steps. If you want skip some steps to reach anything, I'm sure that that's really the result of that you achieve it. It would not be great achievement, or you cannot keep for longer time. Maybe you lose soon because least of people reach agreement with you. While at here, this image is very clear. You see that at here, you cannot, from conventional houses, change the mind of people from conventional houses directly to passive house. For example, people at here, when in practical, thanks for God, we have a very good experience in practical with the clients, that when people come to our office once they want get more knowledge, or they wanted build passive house, that's really, it will be very, very difficult to change mind of people. In for a long time, people used it only block, concrete block with the render of cement sand. You directly you won't say him you should use it, for example, 20 centimeter insulation. You should use it triple glazing windows, and thermal break should be 15 millimeter. You should be at ventilation system. You should minimize the thermal breach, and you should airtight. That's really, if you won't do it, I'm sure that you will not be success. Or if you success, maybe in each year you success only with 2 clients, because the other people they won't jump the skips. But if you want to build passive house, basically after conventional house, you can give an offer for them. For example, for improve quality of each item. For example, for walls, you should just explain for him why you should insulated external walls. Before everything's selected, that item is very important way to reach passive house. For example, in thermal insulation, you should in the beginning neglect insulation of ground floor, and just mention that insulation for external wall and the roof. That is very important. And that's really you should explain for the client or that people on your society, that's really passive house, it's not matter. You should explain it for them. We want to build a house for you that's provided very, very comfort in the air quality for you. And you should select it or priority the items to reach comfort of the houses. before everything, if you want to build comfort house, you should make it insulated, external walls and roof. And after, if the people reach agreement with you to insulated external wall and roof, you can explain is that ground floor is very important, step by step. After this, you should improve quality of windows. After this, installing ventilation system. But maybe just I want to let you know again, most of people at here, when come to our office, they maybe due to economic crisis, they cannot offer it all components of passive house. The first and most wanted item of passive house, thermal insulation, because people want living in houses warm in winter and cooling during summer. Maybe the price of windows or ventilation system, all the system the cost will be very high. So the reason why maybe it will be in the first step will be very difficult to ask people build passive house on with all components. I think it's better build passive house. Build buildings with thermal insulation or triple glazing windows than that you don't want build a house without insulation or triple glazing windows. It's not problem if people wanted ignore ventilation system or ignore the air tightness because due to high cost of building between conventional house and passive house in the first step, it will be very difficult to build passive house. And when you want change mind of people, if you are popular in, for example, in TV shows or in academic center, you gotta highlight the comfort outcomes of energy efficiency building. Or this is a question people ask you, what we achieve it if we build a houses in energy efficiency way. For example, you can select, you can say during living in this building, you will be very comfort, thermal comfort. During the winter is warm, and during the summer is cool. Or also this also you can say during the summer inside of your building is cool, and also you can say you have a good fresh air and you will not need open windows to exchange air. And also you can say this your building will be sound insulated, because in our projected most of buildings we use it rock wool or glass wool. Besides provided thermal insulation, you will achieve sound insulation, and you can sleep very well, or you can stay at home without any noising. Yeah, this is the way. This is outcome of our experience for more than 3 years. That's really is you should be take it easy if your client choose the pathway number one. I think in all societies we have a two option like that. For example, a client or someone come to your office, want get more knowledge about your offered, about something you share it on your website or on your social media. When that client come to your office, maybe that of people reach agreement to build a low energy building. For example, what's a low energy building? That the client reach agreement with you to insulate it just only 10 centimeter or 5 centimeter for external wall, 10 centimeter for the roof, and the people reach agreement with you to add triple glazing windows, but not the passive house thermal break, because we have experience in this way that it will be very, very expensive. Even I have tried to get a passive house profile in Turkey. Unfortunately, until today, I couldn't get passive house profile. When you offered or ordered passive house component, for example, in the abroad or in the Europe, the cost will be very high, or that client stay in that situation. He wants, for example, they want only insulation and windows. They don't want install ventilation system, or they don't want airtight all the building. It means that in that poor societies, you have two type of clients. The first one only go to one step above conventional house, stay in low energy building, but some other maybe nearly only 10% of them, they wanted to make something different, or they wanted to follow passive house international standards, and they wanted to be different in the society. That's really unfortunately the poor people cannot offer passive house, and I think only rich people, because the cost of passive houses will be nearly about 30 or 40% will be more than conventional houses. Maybe you are surprised when you're hearing that 30 or 40% is very high. That's really, it's true. It's not surprised, because if you want make comparison between conventional houses, for example, of Iraqi country or other country, you see that conventional houses at here, the quality is very, very low. For example, if you want to make conventional house of Iraq or in other countries, for example, in Germany, you see that the difference is very high. Because conventional houses at here, it has very low quality, so you see that the difference between conventional and passive house is very high. Yeah, and concerns to build passive house in poor society, that's really the first one, lack of materials in local company. Trust me, more than 80% of passive house companies we ordered from abroad, from Turkey, from Germany, from Swiss, from other countries. It means that the passive house components is not available. Yeah, and also the other concerns is transfer materials in abroad. That's really its extra cost will be for insulation. And another concern is high cost of construction compared with conventional houses. You see that that's really, it's real. At here, when I meet any client, 100% that all clients want to build passive house, but maybe 70% of we lose this opportunity due to high cost. The client is reach agreement every term is with you, but when see the cost is very high, they cannot provide it due to that economic crisis at here. Also, the other concerns at here, it's difficult to find professional craftsmen or a staff for installing, for example, insulation or for ventilation system, for air tightness, or for installing windows properly to airtight it very well. For about our business at here at Iraq, in the beginning, I have tried working just like a worker to make a staff, a team for installing, for example, insulation and ventilation system. And also the other concern is that really maybe it will be difficult to find academic center to test materials. Maybe you find a good material in local, but it has not any data sheet and any property. So you should make it or prepare a data sheet for that material for yourself. That's really all points, 5 points in my real life. I did all of them. I took it material, for example, brick. I go to France, Soleimani to Baghdad, nearly about 500 kilometers just for test one material. And also in the very beginning, I have worked like a worker to make a stuff, how to install, for example, insulation very well. Yeah, and until today, we built only one passive house project. We follow it 100% international passive house standard, and we built nearly about 30 low energy building projects. And we have 2 other project passive house in process. You can see that Atia during 3 years we built only 3 passive houses, but we built it more than 30 different low energy projects. So the reason why in poor societies building passive house will be very, very difficult. And this from here until the end, the last slide, this is, I will show you some pictures that already we built in some of our projects. In this picture in the left, if you see that, we have not a thermal break at here, and I have tried to make it a beam above this insulation. And so to fix it or to minimize the thermal breach, I have covered this steel bars by insulation that go to throw insulation to minimizing thermal breach. And this video, you can see that. Yeah, this is the first project already we have started. This is the passive house. As I said, this is the first one already. It has finished, and we will certify soon in Passive House Institute, inshallah. And you see that in the external wall already, we use 20 centimeter EPS. And in the ground floor, this is the pink layer. We use it also 20 centimeter XPS. Also, this is the same. And also, this is the left image. It's 30 centimeter insulation on the roof. That's really, it's according climate data of that region. that we should use it more than 25 centimeter insulation already. For stay in safe side, we use it 30 centimeter. This is the first time in Iraqi history use it 30 centimeter insulation in the roof of the building. And also in the right side, we are in the process of installing 20 centimeter of 2 other projects. That 2 other projects saved energy nearly about 85, just 5% remain to reach passive house standard, but we cannot say if even remain 1%, we cannot say passive house. And this is the same. And as in the beginning, I have mentioned that really it will be too difficult to say the client is you should use it all components of passive house. So the reason why in most our projects we tried installing only thermal insulation. I know that unfortunately it's not, we cannot say passive house project because passive house projects should be including all components, but we proudly say that if we get back to last 3 years ago, most of people don't know what's a thermal insulation, and most of people don't use insulation. And now today, most of people, when people want to build new houses, they come to our office. They want to make it insulation to save the energy, and also they want to be comfort. And that point is very, very important, that the feedback of people is excellent. That feedback of people describes our work more than our describe before starting the work. The feedback is better than that we expected, and that's really in the beginning. I have said that step by step you should reach passive house. In today we cannot refuse offer of people to insulation. We cannot say if you don't use ventilation, windows, and airtight and insulation, we don't work for you. Step by step we go to passive house. Maybe in next 10 years it's very, very easily people want to build passive house. Now we are in the process changing thinking and minds of people. And also this is two different other projects at here. And this is the left one, installing 10 centimeter of insulation for ground floor. This is the right one also. And this is the real image of the first passive house building. And this is the ventilation system. Already we have installed it. And this is two different types of profile. We install in passive house or in some of low energy buildings. The right one, the white color is aluminium. It's from Cortesio from Spain, and also this one, the black one, it comes from GreeceHPHI, Germany. Also, this windows certified by Passive House Institute. And in this picture, I was in the process explaining for students come to our office. They want to get more knowledge about Passive House. And thanks for providing this opportunity to me. And I am so sorry, I think extended my presentation, and thanks for everyone.
Thank you, Muslim, for your presentation. It was very nice to hear what's happening around Turkey in our neighborhood. And really, congratulations for your effort. We felt that you are really struggling with that. So before we pass to the questions, just a quick question from my side. So are you in contact with some, let's say, local manufacturers or local, let's say, investors to do some things about that? I mean, do you have any contacts like that?
Yeah, already we have contacted with some investor and some manufacturers to, for example, for producing passive house components. But that's really, they mentioned that it's for trade it will be difficult for them for producing passive house components. But it's in some investment projects, for example, in Erbil, it's including more than 30 very huge projects. Now, I don't want to say that, but maybe in upcoming next months, we make contract with some investor to build, for example, a city in passive house standard.
Very nice. Okay.
Yeah.
Okay, we are looking forward to hear good news from Iraq also. Thank you very much, Muslim, for the presentation.
Thank you so much. You're welcome. Just,
please.
I'm sorry if let me just, I want to say something. In later after the presentation, that's really if you have a now some company working in this field in Turkey, please forward the address of them to us, because that's really we are looking for that companies in around Iraq to order passive house component, for example, insulation or also windows. Already we offered 95% insulation ordered from Turkey, but ventilation system and windows is very difficult for me to find it.
Okay, we have noted that, and Dimitris has a comment on that, I think. Dimitris?
Actually, we are currently certifying with the CEOHow 3 different profiles. So maybe you can use that profiles.
Okay, it's great. It's good sound.
Yeah.
Dimitris, I think already I have your email, or
yes,
you can. Yeah, I have your email. Please share if possible. I am so sorry. This season it should be make conservation about the academic, not about the offering. But later I will be thankful if you sharing via email to me this property and data sheet of your profile. Thanks.
Very nice, Muslim. Thank you very much for your comments, and thank you very much, Dimitris, for the support. So hopefully Mohammed is here now with his presentation and connection ready. Hello, Mohammed.
Yeah, I'm so hello. Oh, hello. I'm so sorry. I'm using VPN and sometimes I'm getting interrupted. Yeah, this is I'm afraid that I will get interrupted also. But I will share my screen again.
Please, we are waiting for your presentation.
So do you have me? Yeah. So as I explained, we used the design PH to come up with the preliminary design. After that, we actually transferred the information to the PHPP. In the course of the analysis with the PHPP, we tried all the possibilities for the insulation and the assemblies. And then at the end, we came up with the rock wool, 10 hello? Yeah, 10 centimeter rock wool with the 20 centimeter AAC bricks. This is actually these option was, yeah, you can hear me.
Yes. Yes, we can hear you, Mohammed.
Yeah. So, but this, so one of the most important issues in this construction, we actually there was thermal bridges. Based on this the locations details which has been shown here, we came up with the 5 locations for the thermal bridges, and we calculated all the thermal bridges with the Flixo. And also one of the most challenges for the thermal bridges was the thermal bridge free construction system for the facade, because we use the dry facade to how to install it as a thermal bridge free construction system. We use the thermal break in between the plate here from the facade into the AAC bricks behind the insulation. So we came up with the analysis, and we came up with a good solution for that. This is so these are the construction system which has been shown here. We actually use the insulation with the AAC bricks with this thermal bridge free bolt connection system for the envelopes and also for the pamphlet. And actually we also, for the window system, we use this insulation which is connected to the window, and the window is connected to the insulation layer to have a continuous insulation layer on the envelope of the building. So this is actually the visualization of the AAC bricks with the insulation rock wool 10 centimeter, which is connected into the runners, the supportings for the ceramic porcelain, which is connected into the building envelope through the thermal bridge free connection system. And this is a thermal bridge calculation. And these are the pictures from the actually insulation installation. This is the rock wool with the fiberglass mesh on top of that to be able to have a plaster on top of this insulation system. These are the plaster which has been applied. And this is the insulation on the facade frame, which is supporting the structure for the facade. I mean, the final layer, actually, this porcelain is connected through the insulation into the AAC bricks via the thermal bridge. These are actually the construction going has not been finished yet. You can see the pictures from both sides. And as I mentioned in the beginning of the presentation, we are going to have a PV system, roof-mounted PV system. We have analyzed this roof-mounted system, and then we came up with a 15.7 kilowatt peak. The PV generation output of the system, this PV system will be able to supply the energy need of the building itself, and also be able to export to the grid. And then, but this has not been installed yet. As soon as we finish the building itself, this will be connected on top of the roof with the actually special details to have a thermal bridge free connection to the roof. And we analyzed this PV system by PV Sol. There's some pictures from the PV Sol. What I would like to emphasize at the end of my presentation, we were not able to go for the certification process through this PHI, because PHI are very interested to get this project to get this project in this certification process because they say this is gonna be a run. So, but due to some problems which I investigated, which I found out during the construction, also during the design, also during the investigation from the local markets, we don't have this air blower door test facility. So it is impossible to provide actually air tightness measurements. One of the criteria for the passive house to the passive house institute. But I'm trying to get this from the Turkey maybe or from the Dubai, but it's in the process. And also the window. The window I contacted also ZEBesco, Yasemin. She actually connected me to the window manufacturers in Turkey, and they sent me some samples from the window with the verified U values because we need a window with 0.8 watt per square meter Kelvin U value. We do have a window, PVC window, so aluminum thermal break window, but we don't have a documentation to get right value of the U value and incorporate in the passive house process, passive house PHBP analysis. And also these problems, we cannot provide the good documentation, design documentation in order to launch in the certification process. That's why we didn't go for the PHI now, but we might go at the end of the project. The cost issues, also for the certification, we came up with an offer from PHI and then offered almost 5,000 euro, and the currency exchange rate, it's quite a lot of money to go for the certification process. But anyhow, all these learnings, experiences from this passive house construction are documented. And also we built a good website to share all these knowledges with the building, the authorities in Iran. We have also, we have established an online training system for the passive house internally. So I believe all these learnings or experiences will get noticed from the building sector in Iran, and there are good potential markets in Iran. But I'm in contact with the ZEBesco in order to get their support and to be able actually to provide some facilities like MBHR and the blower door test facilities and also window. Also, we are in contact with the building developers and the authorities of the Building Research Center in Iran. They are very interested in such a building because they actually understand the essential need for improving building energy efficiency in Iran, because we have a lot of energy problem in the summer for the cooling and also in the winter for the heating. And we have actually a problem in power cut and also gas cut all over the year. So they understand the problem, and also they can, according to our building, this is an example we shared with them. They are very happy to actually start using this knowledge for public buildings and also for the private buildings. We are in the beginning, but actually we need the ZEBesco and also the other people in the vicinity of Iran to get this job done in the future. And I believe in the future we will have a good, demands from a building sector internally. But I believe you might have a lot of questions in presentation because the building is not finished yet. But if I finish this building, I will provide a complete presentation to the ZEBesco, and you can share it with the other people in this session. Yeah. So thank you very much for providing this good session, and I wish you all success.
Thank you very much, Mohammed, for the presentation. And again, it is very interesting to see the studies in Iran also. Just a question from my side to you. I hope you can hear me well. I have seen that you are using stone wool in the exterior wall installation, although the buildings are not that high. It's a 3-floor building. Why do you prefer to use stone wool and not EPS or HPS, please?
Yeah, it's a good question. But because before I start going for rock wool or stone wool, I tried other insulation like EPS, XPS, but unfortunately they are flammable. We don't have an unflammable XPS or EPS in Iran, and it's gonna be a problem. And also it's a toxic. I tried, and then they put a flame. I got the samples from the local manufacturers, so it's quite expensive, and also it's flammable. So that's why I decided to go for the rock wool. There is a company which produces rock wool almost 50 years in Iran. So I also got a good documentation for the U value from this company. That's why I went for the rock wool. Yeah.
Okay, thank you very much, Mohammed. Now there are some questions to you from the audience. The question is to Kumsal. They're asking, are you requesting craftsman certificate from the workers and subcontractors for your passive house construction?
Personally, I haven't made a request such a. However, these are the works we need to do together with Passive House Association in CEOHow is also working in this direction. They just got the first Windows certificate, but personally, I didn't request.
Okay. Thank you, Kumsal. Dimitris, the question is to you. It says, you mentioned in your presentation that the cost of the passive house was just 7% higher, but on the other hand, it was giving a less energy consumption plus 76% low operational costs. Now the question is, are these just calculations or measured values? If they are measured values, how?
These are, in this particular project, these are calculations from PHPP. But since 10 years, we have also monitored values, which also says that the performance gap of PHPP is 5 to 10%. So we're pretty confident that these calculations are the correct ones. It is only 7% because in Greece, we don't have extreme conditions. And our local regulations already demands at least 6 centimeters of insulation. So we had 10. The difference is pretty low. And now in Europe, with the NZEB regulations, the demand of systems are also high, with automizations and heat pumps in every single flat when we are speaking for multifamily houses. So our latest study, which we presented last year in the International Passive House Conference, we saw that in multifamily houses, passive house is 10 to 50% less. The price, the construction price is 10 to 50% less than a conventional one, an NZEB one, in Greece at least.
Okay. Thank you,
Thank
Dimitris.
you.
There's a question here about the climate data. I'm pretty knowing the guy who is asking the question. He's a meteorologist, so he's very keen on these meteorologic data. But this question is for you all guys. But let's start from Mohammed, if you can hear me. The question is how you are getting the climate data, the exact climate data in your climate region.
I can help, Özgür. If Mohammad cannot hear us.
There is a delay between our discussions.
Actually,
Are you with me?
Yes, Mohammed, can you hear us? Can you hear the question? I mean, the question is how you are getting the climate data in your region.
Are you with me, Özgür? Yes, I can hear you. Yeah. Yeah, I got this, but actually you might miss my this information from my presentation. I got this climate data from PHI. I sent the actual location of the building to the PHI, and then also they charged me. They provided the climate data for building location. And according to that data, the location was categorized as the warm climate zone. And then I used this data in the PHPP analysis.
Okay. Thank you very much, Mohammed. What about Muslim from your side in Iraq?
Yeah, already I have got the climate data from the government's official center, is meteorologists and earthquake center in Slimani city. I got it, and later I have sent it to Passive House Institute in Germany. They certified it. Later they sent back to me. I have used that data. I got it from government and certified by Passive Institute. Later, I have used it in PHPP.
Very nice, Muslim. Good. Kumsal, what about you?
same. We took it from the Passive House Institute. They obtained it, and we used in the page PP.
Okay. The last word is yours, Dimitris.
Thank you, Özgür. It's the thing that everyone said. In a bit of more detailed calculations, we all trying to obtain data, climate data from the national meteorology in every country, from softwares like Metanorm or other from Passipedia, and then we are completing an Excel file and we are validating with our partners in PHI Germany. So this is the work that all of us are doing. It's the same.
Okay. Thank you very much also, Dimitris, for the explanation. So unfortunately, we are almost done. It was a very enjoyable discussion for me, but we are almost 4 minutes in front of our time. So I would like to thank to the people who is watching us, who is following Zero Build Forum, and who was with us in this session. And I would like to thank you all for your very successful and lovely presentations. And wish you and hope to see you again next year in Zero Build Turkey. That will be done probably around March 2022. Thank you very much for everything and hope to see you soon.
Thank you, Özgür, for the great moderation.
Thank you. Thank you. See you soon.
Thank you.
Bye-bye.
Thank you so much.
Bye-bye.
Mohammed, I know that you will hear us 5 minutes later.